Nucleophilic addition is a characteristic reaction of aldehydes and ketones and probably the most important reaction that you need to know about. As the name suggests, a nucleophile attacks the carbonyl functional group and adds to the molecule. Now this is not a substitution or an elimination reaction, nothing that gets kicked out and two molecules react together to form one. Now let's consider a nucleophile first. Let's say the negatively charged cyanide ion which approaches a carbonyl. We know that the nucleophilic cyanide ion will be attracted to an electron-deficient area in the carbonyl, and we have just learned from our previous checkpoint that the partially positive carbon is an electrophilic site. Now of course, this means that the cyanide ion will immediately attack the carbon, donating a lone pair of electrons to form a bond with the carbon atom as shown here. However, you know that we cannot have 5 bonds on a carbon atom. In order for the cyanide to successfully attack, we have to break one of the other existing bonds already. We also remember from our previous checkpoint that the pi bond in the carbonyl is weaker and easily broken. As such, the pi bond, the CO pi bond will break and the lone pair of electrons will be moved to the oxygen atom. The carbon atom now has 4 bonds again, which is correct, the number of correct bonds that is supposed to be bonded to carbon atom. However, there is still a negative charge on the oxygen atom and we can deal with that by protonating the molecule. Now you should not miss out the protonation step when drawing the mechanism for nucleophilic addition. This is in summary what happens in a nucleophilic addition reaction. The cyanide nucleophile attacks the carbonyl carbon, the carbon-oxygen pi bond gets broken and there's an overall addition of the cyanide molecule to the carbonyl. The resulting molecule is called a cyanohydrine. Now this molecule may seem complicated, but it's actually not. If you realize, everything that happens here is logical and always based on the same old principles. Nucleophiles will attack electrophiles and the weakest bond always breaks. This also ties in with the reactivity of the carbonyl functional group. The electrophilic carbon atom will get attacked and the weak pi bond will get broken.